In the last few months, there have been quite a few discoveries and updates about Jupiter and its moons. Discoveries made by the James Webb Space Telescope, but also by the Juno mission that's still flying around Jupiter and is still collecting a lot of data, taking incredible images of this planet, and, in the process, solving a lot of mysteries. And so in this video, let's discuss some of these new discoveries in just the last few months, because there have been quite a few. And let's start with something super cool. Something that we don't see very often. A tremendously large lightning bolt detected on the surface, captured by the Juno probe as it was essentially flying very close to one of the poles. And though on Earth we usually expect this from some kind of a cloud, with most lightning strikes usually happening very close to the equator, on Jupiter this cloud is very different. It very likely contains ammonia and water, and more specifically it's actually located extremely close to the poles. So it's really the polar regions on Jupiter that seem to possess the most lightning. Here is the artistic representation of what all of this might look like. But one of the images shot by Juno contained one of these lightning strikes that's absolutely tremendous in size, possibly at least a few hundred kilometers long, and obviously also a lot more powerful, although the exact power of this is currently unknown. And in the last few months, the data from Juno mission revealed some incredible details about the magnetosphere of Jupiter and actually solved one of the major mysteries. And that's because the way that Juno orbits around Jupiter makes it orbit around the planet in a very wide arc, which means that it transfers through large parts of Jupiter's magnetosphere, but also goes beyond the magnetosphere, allowing it to measure overall changes. Now it's done over 50 orbits now, and during that time it was always measuring the strength of magnetosphere, with one of the first discoveries being in regards to the overall edge of the magnetic field. Just like predicted, there seem to be these giant swirling waves right at the boundary of the solar wind and the Jupiter's magnetosphere. We actually have a name for this. It's known as the Kelvin-Helmholtz instability, something that forms in a lot of different conditions on planet Earth as well, such as for example when certain types of clouds form. And these instabilities will usually occur when there is a difference in velocity at the boundary between two different fluids. Although in this case the fluid is the magnetosphere, formed by the plasma from Jupiter. And so here the data confirmed that these waves definitely exist and are definitely huge in size. But this was just one of the first discoveries. A much more important discovery in regards to magnetosphere ended up solving one of the major mysteries. One property that makes Jupiter very strange are these unusual bands you see right here. And you can see here that for some reason they seem to move in different directions. Some move westwards, some move eastwards. And they also generally change with time. But how exactly any of this works, or why they change with time, was never really known. But one of the more recent studies, once again using magnetosphere, focused on a feature of Jupiter that's definitely a lot less known: Jupiter's Great Blue Spot. Not to be confused with the Great Red Spot. This Great Blue Spot is a result of magnetosphere, and turns out that the spot was actually moving eastwards in most of the recent data. But it's also slowing down its movement, and potentially will actually change directions in near future, which suggests a major connection between the changing appearance of Jupiter, which you can see right here, this is only 10 years apart, in this case visible in the infrared light, the movement of the blue spot, which seems to be actually correlated with the changes, and of course the changes of these stripes. And it's now believed that all of this is very likely driven by the planet's magnetic field. The waves produced by the magnetic field, somewhere inside Jupiter, potentially drive the changes in the upper atmosphere. This phenomenon is known as the torsional oscillation, and for the past few decades this was actually studied on the Sun quite actively. So today there's generally a pretty good understanding of how these unusual phenomena work. The magnetic interaction inside the Sun tends to affect a lot of surface features, including sunspots. And something on a smaller scale seems to happen on Jupiter as well, but instead of sunspots, we basically get Jupiter stripes. And because it's an oscillation, basically things here move back and forth, it seems to result in these unusual patterns, which are obviously still kind of mysterious, but a little bit less mysterious because of these new discoveries. Specifically, it's still uncertain how this produces all of these infrared changes, and how this then affects the upper atmosphere. But definitely some cool discoveries about things we never really knew before. And then we also have some really cool discoveries about the Galilean moons, or basically the moons of Jupiter. And in this case, many of these discoveries came from the James Webb Space Telescope, because apart from Jupiter, it also took a look at a lot of the moons. But the first cool discoveries and first observations once again came from Juno, specifically this picture. Incredible new observations of the closest moon Io, with pictures taken at an altitude of about 35,000 kilometers, both in visible and the infrared light. And so far this was the closest such flyby, creating these absolutely mind-blowing images. As you might already know, this is the most active volcanic object in the entire solar system. But the thing is, in December of 2023 and February of 2024, it's going to be flying by even closer, only 1500 kilometers away from the surface, which is about this far. And so we're going to be treated to some incredible images in just the next few months. Something we've never seen before, and something that's definitely going to be very surprising. But the James Webb was also able to take a look at the moon, and in the process was able to actually see certain chemical elements being emitted by the volcanoes. In this case, it wasn't anything groundbreaking or super exciting, but it did discover things like sulfur monoxide, which is generally very difficult to detect. The actual image looked something like this. Here it's showing us eruptions from Kanehekili Fluctus and Volkipatera. And so inside this infrared image, spectroscopic analysis revealed definitive signs of certain chemicals. But in this case, it's really more of a proof of concept and the ability to detect this rather than the actual discovery that's really exciting here. However, the other moon, Ganymede, that you see right here, did present us with something very interesting and somewhat unexpected. And you can sort of see this on the image. And so these unusual red spots you see, that's a result of a detection of hydrogen peroxide. That same stuff most of us have at home, and that once upon a time, like years ago, I tried to use to whiten my teeth because someone mentioned it actually works. Anyway, not particularly relevant. What is relevant and what's important is that it seems to have hydrogen peroxide on the surface. And more intriguingly, it seems to be mostly in the polar regions, the North Pole or the South Pole. And why it's here and why it's in those regions is sort of unusual and was completely unexpected when the scientists discovered it. Okay, first of all, where exactly is it coming from? Apparently it's a result of extremely strong radiation coming from Jupiter itself. And as a lot of the radiation here strikes the surface of the moons, it changes a lot of elements on the surface. One of these elements is water. Water ice transforms into something else, and this is known as water ice radiolysis. The water ice dissociates into oxygen and hydrogen and then becomes hydrogen peroxide, and also a few other things like, for example, ozone, or even pure oxygen. And the thing is, it has been discovered on Europa before, but on Europa it does seem to be in many different places. It's not localized to any specific location, but on Ganymede it's either in the north or in the south. And it took a while for the scientists to realize that it's mostly because of the magnetic field inside Ganymede. Ganymede is the only moon we know of that has a relatively strong magnetosphere and is even able to produce aurora. And turns out it also affects the surface chemistry. And so here, as Jupiter produces some of these elements, many of them then seem to be guided to specific regions around the moon in a very similar way that the charged particles coming from the sun are guided by Earth's magnetosphere toward the polar regions as well. Now here we get aurora, but on Ganymede it looks like it actually deposits certain chemicals, such as hydrogen peroxide, in specific polar regions. So in essence, the magnetosphere here acts as a kind of a chemical funnel. It actually means that if one day we ever go to Ganymede, we'll find these locations where pretty much everything is sort of concentrated. For example, we'll find large deposits of molecular oxygen or even hydrogen peroxide, which will be particularly great if any of these future astronauts need to whiten their teeth. So definitely a pretty cool discovery. And because all of this is pretty much driven by magnetosphere, it's a very intriguing mechanism that might have affected a lot of other moons in other systems as well, or even other planets, assuming they have similar conditions and similar phenomena. For example, something like this might also exist on Mercury, which contains a magnetosphere as well, something that maybe future studies might investigate. But apart from physical observations, there was also at least one theoretical study that discovered something unusual, potentially explaining the differences between these moons. And here the assumption was that at some point, Jupiter, when it was really young, was probably really hot, and was also at least 10,000 times brighter than it is today. And as a result of this, all four moons were probably exposed to different amounts of brightness and radiation in the early Jupiter system, and specifically the closest moons, Io and Europa, very likely received most radiation, with all of this radiation coming from early Jupiter, very likely vaporizing all of the water, stripping these moons of their volatiles and making them extremely dry and somewhat rocky. Now Europa is known to be an icy moon and it does have a relatively large ocean underneath, but it's expected to contain less water and also contain a relatively large core compared to the more distant Ganymede and Callisto. And so this recent study that you can find in the description essentially explains why there is a certain gradient that these 4 moons seem to contain. For example, the farther they get from Jupiter, the lower density they seem to have, and also the higher the proportion of water ice, with Callisto actually being the least dense and having most water by mass. And Io seems to have least water of anything in the solar system, implying that Ganymede and Callisto were far enough that this early bright Jupiter might have not affected them as much, whereas Io and Europa were close enough where the heat from early Jupiter potentially vaporized large amounts of water. And the calculations here even imply that at some point Io might have had a temperature of approximately 27 degrees Celsius on the surface. In theory, this would be enough to contain liquid ocean, but because it was a relatively small moon and potentially had no atmosphere, it's quite likely that water just vaporized completely in a relatively short period of time. And though it might have had some kind of a water vapor atmosphere for some time, even that would be gone pretty quickly. Nevertheless, definitely a pretty cool observation and a pretty cool discovery. But when it comes to other discoveries, at least for now that's pretty much it. But we're definitely going to be coming back and talking more about Jupiter very soon. So check out some of the previous videos in the description. Thank you for watching, maybe subscribe, share this with someone who loves learning about space and sciences, come back tomorrow to learn something else, and maybe support this channel on Patreon by joining a channel membership or by buying the Wonderful Person t-shirt you can find in the description. And before you go, if you stayed that long, you might also want to check out this incredible poster that NASA recently released for anyone to download that sort of celebrates 50th orbit of Juno around Jupiter. It's called 50 Orbits of Jupiter, and it shows us the best of the best that Juno so far was able to produce, revealing so many different incredible images of the planet and of course of its moons. Definitely some cool stuff, but the mission is far from over. Anyway, come back tomorrow to learn something else. I'll see you tomorrow, stay wonderful, and as always, bye bye.